Welcome to the Machine Learning Essentials series. My name is Seth Juarez. In this episode, we're going to talk about low-code options available for machine learning in the cloud. Let's first start with data science. Data science is an interdisciplinary field that uses scientific methods, processes, and algorithms and systems to extract knowledge and insights from many structural and unstructured data. Now, that sounded boring because, again, it came from Wikipedia. So why bring this up in a Machine Learning Essentials video? Well, it turns out that the basic steps for making machine learning models follow the scientific method. Seriously. First, you got to start with a question. You look around for some data, you form a hypothesis about what data or machine learning models might answer the question, then you try it out. The funny thing about this process is that if we get it exactly right the first time, we feel like something went horribly wrong. We literally expect to be going through this process a couple of times for a while. It gets even more interesting when you consider that each machine learning model we think might work also has its own set of parameters that need looking after. Essentially, if you are new to the machine learning process, it's extremely daunting. How do I even know where to start? And if you're a seasoned data scientist, this process is time-consuming and often quite tedious. For both sets of folks, it can also be costly. It turns out that data scientists at Microsoft were also frustrated with the same problem a couple years ago, and automated machine learning, or AutoML, was invented to solve this very problem. It is essentially the process of automating the time-consuming iterative tasks of machine learning model development. It allows data scientists, analysts, and developers to build ML models with high scale, efficiency, and productivity, all while sustaining model quality. Automated ML is based on the breakthrough from our Microsoft research division, who literally got bored doing the same thing over and over again. You can apply automated ML when you want Azure Machine Learning to train and tune a model for you using the target metric you specify. Automated ML democratizes the machine learning model development process and empowers its user, no matter their data science expertise, to identify an end-to-end machine learning pipeline for any problem. Data scientists, analysts, and developers across industries can use automated ML to do a couple of things. Those include implement a machine learning solution without extensive programming knowledge, save time and resources, leverage data science best practices, provide agile problem solving, etc. Once you have uploaded your data set, automated machine learning can provide solutions for standard machine learning scenarios like classification, regression, and even time series forecasting. So how does it work? Well, during training, Azure Machine Learning creates a number of pipelines in parallel that try different algorithms and parameters for you. The service iterates through machine learning algorithms paired with feature selections, where each iteration produces a model with a training score. The higher the score, the better the model is considered to fit your data. It will stop once it hits the exit criteria defined in the experiment. The best part is that this doesn't just loop through all possible machine learning algorithms. It looks at how a model performs and actually recommends what model to try next. Essentially, if you like this model, you're really going to like the next one. Does that sound familiar? Automated machine learning uses machine learning to, well, do machine learning. Automated machine learning doesn't just recommend the best models to try. If models aren't performing as well as others, remember this runs in parallel, then it stops execution. This process of choosing the best model, again using machine learning, and early stopping saves both compute time as well as your time. This whole thing empowers professional and non-professional data scientists to build machine learning models rapidly. It also automates time-consuming and iterative tasks of model development using breakthrough research, and it helps you accelerate time to market. In other words, once the best model rises to the top with respect to the metrics that you choose, deploying that model into a production environment can be done with a single click. Automated machine learning is an excellent no-code way to get started with machine learning. If anything, it helps shorten the research period down quite a bit. Essentially, you have an automated way to figure out which type of models work with the question you are trying to answer and the available data. What if you want to further tune or experiment with what you've learned, but also in a low-code way? Turns out there's an Azure Machine Learning Designer that lets you visually connect data sets and modules on an interactive canvas to create machine learning models. The designer gives you a visual canvas to build, test, and deploy machine learning models. Almost everything you need to build sophisticated machine learning models is included. You can drag and drop datasets and modules directly onto a canvas. You can connect those modules to create what's called a pipeline draft. You can submit a pipeline run using the compute resources in your Azure Machine Learning workspace. And you can convert your training pipelines to inference pipelines. You can also publish your pipelines to a REST pipeline endpoint to submit a new pipeline that runs with different parameters and datasets. You can also publish a training pipeline to reuse a single pipeline to train multiple models while changing parameters and dataset. What if you want to do batch inference? Well, you can publish a batch inference pipeline to make predictions on new data by using a previously trained model. You can also deploy a real-time inference pipeline to real-time endpoint to make predictions on new data and real time. Now, I know that's a lot, so let's go through each concept one by one. Let's talk about a pipeline. A pipeline consists of datasets and analytical modules which you can connect. Pipelines have many uses. You can make a pipeline that trains a single model or one that trains multiple models. You can create a pipeline that makes predictions in real time or in batch. Or you can make a pipeline that only cleans your data. Pipelines let you reuse your work and organize your projects. As you edit a pipeline in the designer, your progress is saved as a pipeline draft. You can edit a pipeline draft at any point by adding or removing modules, configuring compute targets, creating parameters, and so on. When you're ready to run your pipeline draft, you submit a run. Each time you run a pipeline, the configuration of the pipeline and its results are stored in your workspace as a pipeline run. You can go back to any pipeline run to inspect it for troubleshooting or auditing purposes, and you can even clone a pipeline run to create a new pipeline draft for you to edit. Pipeline runs are grouped into experiments to organize run history. You can set experiments for every pipeline run. Again, without any code. So let's talk about data. The same data sets that were used when doing automated machine learning are also available as drag and drop item directly onto a pipeline draft. Several sample datasets are included to boot in the designer for you to experiment with. You can also register more datasets as you need them. Now let's talk about modules. A module is basically an algorithm that you can perform on your data. The designer has several modules ranging from data ingress functions to training, scoring, and validation processes. A module may also have a set of parameters that you can use to configure the module's internal algorithms. When you select a module on the canvas, the module's parameters are displayed in the Properties pane to the right of the canvas. You can modify the parameters in that pane to tune your model. You can also set the compute resources for individual modules in the designer. What kind of modules are available? I'm glad you asked. There are modules for data prep, standard machine learning algorithms, including regression, clustering, classification, as well as modules for building and evaluating models. For those that already have amazing machine learning code, you can even add your own custom modules with either or both Python and R embedded into the pipeline. Where does all of this run? Great question. You can use compute resources from your workspace to run your pipeline and host your deployed models as real-time endpoints or pipeline endpoints for batch inference. Not only that, but you can also specify where each module in the pipeline should run. You could also create an Azure Machine Learning compute cluster and spread the compute across multiple machines by simply specifying where each module runs. This can significantly shorten the time needed to get machine learning solutions. Once you've got something that works, you can deploy a pipeline as a real-time endpoint. The real-time endpoint creates an interface between an external application and your scoring model. A call to a real-time endpoint returns prediction results to the application in real time. To make a call to a real-time endpoint, you basically pass the API key that was created for you when you deployed the endpoint. The endpoint is based on REST, a popular architecture choice for web programming projects. What about ML ops? What if the data set changes and I want a fresh model, say, once a week? Well, with the Azure Machine Learning Designer, you can also publish a pipeline to a pipeline endpoint. Like a real-time endpoint, a pipeline endpoint lets you submit new pipeline runs from external applications using REST calls. This means that you can automate the training or even retraining of a model by a simple call to a REST API. You can also use these published pipeline endpoints to perform batch inferencing, process new data, and much more. Finally, you can publish multiple pipelines to a single pipeline endpoint and specify which pipeline version to run. In summary, with automated machine learning, you can provide real business value with machine learning without spending a lot of time bogged down in the complex minutia of the data science process. This has all been, automated. If you are a seasoned data scientist, this should be music to your ears. If you're just getting started with machine learning, it is a great place to start. Once the AutoML process has worked for you, why not investigate fine-tuning what it has learned with the Azure Machine Learning Designer? The easy-to-use drag-and-drop interface can keep you focused on business value while providing avenues for creating predictive endpoints as well as operational pipeline endpoints for easily getting started with ML ops. I guess the last thing to say is go forth and do. With all the power now available at your fingertips with machine learning, why not grab a handy data set and solve a machine learning problem today?